Hello students, today we shall discuss about the module 4 part B section. This is a microprocessor. Module, the part B section is fully of the theory, fully theory. You will study about the microprocessor, introduction to microprocessor, how evolution of microprocessor inside a microprocessor, basic microprocessor instruction, addressing mode. Let us see what are those. So coming into an introduction to microprocessor. A microprocessor is a programmable device that accepts binary data from an input device, process the data according to the instruction stored in the memory and provide results as output. The popular brands of microprocessor are 8-bit, 16-bit, 32-bit and 64-bit microprocessor from international chains like Intel, Motorola, etc. So the definition you need to know here, it is a programmable device. Okay, so you need to know what are the bits available in the microprocessor. Microprocessor based system. Any microprocessor based system essentially comprises three parts, namely processor, memory, peripheral, input-output devices. There are three parts are interconnected by. So how are the microprocessor and input-output peripherals connected? They are connected using a bus. So there are different types of buses, that is data bus, control bus, data bus, address bus and control bus. You can see here address bus, data bus and a control bus which is connected to a microprocessor and memory and input-output devices. So the functions carried out inside the microprocessor. The memory stores the binary instruction and data from the microprocessor. So this is a work, what do the memory do? So input-output devices means through which the microprocessor interacts with the outside world, keyboard, A to D converter, switches, cameras, scanners. A bus is a communication made up of group of wire that carries information in the form of bits between the processing unit and the peripheral devices. These are the few functions which is carried out inside the microprocessor. So types of bus. There are different bus as we come across. First one is the address bus. Address bus, it is usually a unidirectional bus and is used by a CPU to send out the address of the memory location to be accessed. Data bus is a bidirectional, that is a data flow occurs both to and from the microprocessor and peripherals. The control bus is a bidirectional which sends out the control signals to memory, input output ports and other peripheral devices to ensure proper operations. So coming into the bus interface between microprocessor and its peripherals. So you can see here bus interface between the microprocessor and peripherals. So here you have an address bus which is connected to a RAM and ROM, and there is a data bus which is also connected to a RAM ROM, and you can see where it is connected also. So you have a address bus which is connected to a output interface, output devices, input interface and input devices. So this is how the connection is being done in the 8085 microprocessor. So coming into the inside of a microprocessor, there are few functional blocks of the microprocessor. So the important functional blocks includes the arithmetic logical unit, the register file and a control unit. The control bus which controls all the data. So data bus which is sending the data. You can see there is a control unit. ALU means arithmetical logical unit, register file, and a data bus and internal bus which is connected here. Let us look into the inside what we just come across those things again. So arithmetical logical unit, register file means program counter, instruction register, buffer register, status register, stack pointer, general purpose register, temporary register. These are the register file, and you also have a control unit which controls all the things. So this is the descriptive block diagram of the microprocessor. You can see a demultiplexer which is connected to a general purpose register, and then it is connected to a multiplexer, and then to a ALU. You have a status register which shows the status, the result which has been sent to a data bus. There is a stack pointer which points to the location, program counter which is connected to an address bus, as well as you have a control unit which the control bus is connected to it. So this is a descriptive block diagram of the microprocessor. Coming into a register function, there are few register function. We will look into it in this class. The program counter is a register that stores the address of the next instruction to be executed. Instruction register stores the code of the instruction currently being executed. Buffer register interface the microprocessor within its memory system. The two standard buffer registers are the memory address register and memory buffer register. So coming into a functions of the register, there are few functions. Though status register, it is denoted by SR, that stores the status outputs of the result of an operation and gives additional information about the result of an ALU operation. Stack pointer is a register used to store the address of the memory location belonging to the most recent entry in the stack. Push and pop instruction. General purpose register, they are used explicitly to store the data and address information. So temporary register, these are used when data have to be stored during the execution of a machine instruction.